I've written a console program to do the performance measurements, and I'm using a base class called performance test right here to run the performance, the different performance tests. I have three methods here: measure test A, measure test B, and measure test C. So these are virtual methods, and in any derived class I will put the test code in here. And the format is always that the first one, test A, is the baseline test. So this would be unmodified slow code, and then we have two methods B and C available to try out different kinds of optimizations. And then for the actual performance test down here, the performance test is fairly simple. Basically what I do is I go through these test A, test B, and test C methods, and I repeat them a number of times. So you can see there's a constant here, default repetitions, with a value of 10. I basically repeat the tests 10 times to average out the effects of the garbage collector, because an ill-timed collection of the garbage collector can really slow down one of the tests. So if we just run it 10 times, then we average out that effect. To measure performance, you're supposed to use the stopwatch class in C#. So when you're doing benchmarking, please don't use date time. Always use stopwatch, because stopwatch is a specialized class for measuring time spans extremely accurately. So you can see I always start by restarting a stopwatch, doing the test, stopping the stopwatch, and then I have the elapsed milliseconds right here, and I'm adding that to a variable. And then in the end, you can see right here, I'm returning that total value divided by the number of repetitions. So we're doing 10 repetitions, so we have the total elapsed time for every method, and then divided by the number of repetitions gives you the average execution time. Okay, back to the program. So the next test is a comparison of for and Foreach. So let me show you the code. The test is here. Here we go. So I create a list with 1 million elements. It's a list of integers, and I fill the list with random numbers. So super simple, 1 million integers, and every list element is just a random number. And then this test uses a for each loop to loop through the list, and this test uses a normal for loop with an integer index variable. And that's it. So let's run those tests and see what happens. And here's the result: 273 milliseconds for the for each loop and 112 for the for loop. So the for loop is roughly twice as fast as the for each loop. So to show you why that is happening, let me go back to the intermediate code. We can take a look at the compiled code and see how the loops have been implemented. So here's the test class. So let me scroll down. So that's the constructor. And here is measure test A. And you can see that the for each loop uses an enumerator, a generic enumerator, to loop through the list. So the first thing you have to do is you have to call the list and call the getEnumerator method, and that gets you the enumerator. And then the enumerator itself has a current property to access the current value of the current element that you're looking at. And there's a move next method that will move the enumerator to the next element in the list. And move next is you can see it's a Boolean method. It returns bool, and this branch instruction basically jumps back to 12. So it loops this bit of code as long as the enumerator returns a value. And as soon as move next returns false, we reach this point, and this leave instruction will exit the method. So you can see that the for each loop is implemented by using an enumerator class and then repeatedly calling move next and accessing the current property to get the data. So that's a lot more overhead than a simple for loop, which is implemented here. It's this bit of code. You can see that the for loop, it doesn't really use any classes at all. The only place where a class is being used, where a method call is being used, is here, where I access the element in the list, but the loop itself is just this piece of code. So a for loop, it can be implemented with only a few CIL instructions, and it doesn't require any specialized classes. So that's why a for loop is much faster than a for each loop. Now keep in mind, when you are looping through an array, there's no difference between the two, because the C# compiler is very smart. If you use for each on an array, the compiler will generate a normal for loop behind the scenes. So you won't see any difference in performance. But for the more complex collection classes, you can see that there is a difference. It's about a factor of 2.